Okay, we're going to look at geometric series today, a couple of different types. At the very top of our paper, we're going to talk about finite series. So this is finite geometric series. So we're looking at the terms of a geometric sequence where we're multiplying, and we'll use the formula. So the formula for finite series is the sum of the first n terms, however many terms you want it to be, is the first term, A1, times parentheses 1 minus r to the n power over 1 minus r. The one nice thing about this that's different from the arithmetic series you did yesterday is we do not have to know what the last term of the series is. If we know the first term and we know what r is and we know how many terms we have, that's totally all we need. So our first example that I'm going to do, I'm just going to write out the series. So let's say I have 3 plus 6 plus 12 plus ... and that we are being asked to find the sum of the first 10 terms. So since it's only 10 terms, I could theoretically figure out the pattern, write out all 10 terms, and then add them up. But if it was more than 10, that would be a real pain. So using the formula actually is a little bit faster, especially if you're using a calculator. So the first thing that we need is the first term, A1. So the first term is 3. And then we make our little parentheses. It's 1 minus r. So what am I multiplying by each time? 2. So that means r equals 2. So we're going to have 1 minus 2, and then to the 10th power, because we want to do 10 terms, over 1 minus r, which is just 1 minus 2. So I like to do this in somewhat smaller pieces. I would leave the 3 for a second. I would type in that top number on my calculator, which I have in my notes. So if I do 1 minus 2 to the 10th power, I get negative 1,023. And then if I take 1 minus 2, that's just negative 1. So that's going to cancel out the negative. So really we're just taking 3 times 1,023, and my final answer will be 3,069. So very quickly with the calculator, you could figure out, even if I'd asked you to do the 100th term, it wouldn't take you any more work using this formula. Because you would just have to put the numbers in, use your calculator to quickly do the power, and it's all good. Okay? And this is called a finite series because it stops at 10 terms. So let's do another one. Let's say that I have 2 minus 6 plus 18 minus 54 plus, and it just keeps going. And they want us to find the sum of the first 12 terms. Now if I'm looking at the difference here, what we're multiplying by, I notice it's going positive, negative, which means that my ratio has to be negative. And what is that negative number? 3. Looks like we're multiplying by negative 3. Negative 3, because we go from 2 to negative 6 to positive 18 to negative 54. So, and then my first term is 2. So I put 2 here. This is my A1. And then on the top of my fraction, I'll have 1 minus, and here's the kicker. You're going to do some little parentheses. Negative 3 in the little parentheses to the 12th power. And that is so that this negative and this negative do not cancel because they're separate. Otherwise, your calculator won't like that. And then I'll have 1 minus negative 3 in the bottom. So the negative for the ratio changes things a little bit. Okay, so I'm going to leave the 2 out front. I would type the top into the calculator with these little parentheses. 1 minus parentheses, negative 3, close parentheses, to the 12th. I would type that in. If you want to try that, that top number should be negative 531,440. So if you want to take a moment to try that, you can. And then 1 minus negative 4, those will cancel, become plus, and we get 4 on the bottom. And then you can divide this and then take it times 2, or you can take 2 times this and divide by 4. Whatever order you want to type that in at this point. And we get negative 265,720. So these get to be big numbers, and you're multiplying. The numbers can get really big really fast, and so to go all the way out to 12 terms, we would have had some really big numbers, and you would have had 12 numbers to add together. This is still shorter even if there's only 12 terms. I could theoretically keep multiplying by -3 until I have all 12 terms, and then I could add them up. That is an option. This formula was mostly created because sometimes they're going to want you to do 100 terms or 1,000 terms, and those would be really, it would just be too much to do with all the terms. Okay, we're going to do one more of these, and then we're going to switch gears. So the next one that we're going to do is it's got some fractions. So we're going to start off with 1/12 plus 1/6 plus 1/3 plus 2/3. And I think that these are a little bit more difficult than some of the others, so I'm going to show you a trick. I know my first term, my A1, is 1/12. Okay, so that's not too terribly hard. But trying to figure out the ratio for this is a little difficult. So what you can do is change these so they all have common denominators. So if I look, I've got 12 and 6 and 3 and 3. So 12 would be a good common denominator. I could have 1/12, and then if I take the 6 and the 1 times 2, I would have 2/12. And then I have thirds here, so I could take that times 4, good, 4/12. I already got it figured out. I could also take this one times 4 and get 8/12. And that'll help me compare these fractions a little bit easier. Yeah, he's right. So notice the bottom number staying the same. The top number is getting multiplied by 2. So that means my ratio is 2/1, or we could just say it's 2. And so when you have that common denominator, then you can just focus on what's happening to the top number. Sometimes it'll be easy to tell what's happening to the top and to the bottom, and we've done some of those. This one's a little trickier, so I thought I'd throw one of those in. So let's just say randomly we're going to do the sum of the first 13 terms. I don't really feel like taking all of these times 2 and simplifying the fractions and adding a bunch of fractions. Adding 13 different fractions by hand doesn't sound like fun to me. So we're going to use the formula. So the first term is 1/12. And then inside the parentheses, we'd have 1 minus 2 to the 13th power, because we're looking for the sum of the first 13 terms, and then over 1 minus 2. So I'm going to do this in pieces. I'm going to leave the 1/12 alone for a second, and I'm going to do the top part. 1 minus 2 to the 13th, it was just a positive 2, so you can just type that in, and you end up with negative 8,191. On the bottom, I end up with negative 1. So really what this is going to be is just 1/12 times positive 8,091 over 1. I can take the negatives out. And so just using some basic fraction skills, you multiply the top, multiply the bottom, it's 8191 over 12. And you could use your calculator to see if that actually simplifies, but it doesn't. I wouldn't type this whole thing into the calculator. You get some sort of weird decimal that may or may not be changeable back to a fraction using that little math button. But basically, I would just do it that way. I would do this on the calculator, and then I know what that is, and then I would just use a little bit of some fraction knowledge, knowing that I just multiply the numerators, denominators. I would just leave it like that. You could change it to a mixed number, you could change it to a decimal, but as long as this doesn't reduce at all, I would just leave that fraction the weird way that it is. Okay, so now for infinite series. Infinite geometric series have answers, which seems a little weird because you're adding forever and ever and ever. So an infinite geometric series. So these have an answer only if your r is a fraction and you keep adding smaller and smaller and smaller numbers. Actually, you know what? I think I can draw a little picture to illustrate this. Let's say that I have the infinite geometric series that starts like this. 1/2 plus 1/4 plus 1/8 plus blah, blah, blah. And let's say that I want to know the infinite sum that goes on forever. And so what would happen with this is they just use an S without a number, okay? There's also a way to do this with the sigma notation where you put an infinity as the end. But we're just going to find the sum of all of it, okay? So we're going to find what I would call the forever sum. And you're like, but if you keep adding forever and ever and ever, doesn't the number get bigger? Well, it gets bigger, but it has what we call a limit. So I'm going to draw a little picture out to the side to illustrate this one for you. I'm going to attempt to draw a square. Okay? I'm going to draw a square like this. So the first number is 1/2. And so what I'm going to do is I'm going to color in the top half of the square like this.
X equals?
Uh-huh. Yep. So I'm going to do a little picture to show you how it gets an answer. So I colored in a half. I have half. Then I'm going to add to it a fourth. So if I take this half that I didn't color in and do half of that, that would be a fourth, right? So now I have a half plus a fourth. Then if I want to do an eighth, I need a half of what's left. So I could do this. I'll divide it this way and do half of what's left. And then the next number would be a 16th, right? Because I'm taking half each time, so I divide this in half this way, color in a half. And it's going to get very small here pretty soon. Then I'm going to take a half of that, which would be 1/32. I'm going to divide that in half and do this. And then I'm going to take that little piece and divide it in half. And theoretically, if your pencil lead were small enough, you could keep going. It's never going to go outside this square. So we're going to end up with 1 whole square. Isn't that amazing? Now, if it's not a half, you end up with a different portion of it. But this is just to kind of illustrate to you that even though we're still adding to it, if the numbers are getting smaller and smaller, and if it's multiplying, this only works for geometric series where r is a fraction. So I'm going to make a little note over here. Only works for geometric series where the absolute value of r, so it doesn't matter if it's positive or negative, is less than 1. It's got to be a fraction, something smaller than 1. And there's a formula that goes along with this. So the formula, I suppose we ought to write down, is actually really easy. The formula is S equals A1 over 1 minus R. So I'm going to write that down as our formula. I didn't box the formula at the top. I should have. Oops. So that's the formula we're going to use. So let's try that on what we just did with the picture. So my first term was 1/2. Okay? And then I'm dividing that by 1 minus R. Well, my R going from here to here and here to here was also multiplying by a half because the top stayed 1 but the bottom changed to 2. So it's 1 minus a half. So I get 1/2 divided by 1/2. Get excited. The answer's 1. So the pictures are kind of cool just as a way to illustrate that you do get an actual answer, even though this is a forever sum, an infinite sum. But the formula is a little bit faster. So let's do another one. We'll do some that don't have... on the other page. Oh. We're going to do probably 3 more examples, but they're going to go quick because the formula is short. We're not going to draw the picture on each one. So let's say I do 25 plus 5 plus 1 plus da-da-da-da-da. And we want to find that forever sum, that infinite sum. If I add this forever and ever and ever, what it's going to be. So my first term is 25. That goes on the top. Then I have to figure out what the R is. So it looks like it's dividing by 5, what can I say it's multiplying by? Do you remember that from doing our geometric sequences?
Negative plus?
No. Be 1/5. So it'd be multiplying by 1/5. So if it looks like it's dividing by 5, that's the same thing as taking a fifth every time. So we would say that R on this one is 1/5. So you have 1 minus 1/5. Okay? And you could type all this in your calculator, do 25 divided by parentheses, 1 minus 1 divided by 5, like this. Or you could figure out the fractions and do some really serious subtraction and fraction division. You're welcome to do that. You know how. It just would take a little while. And so if we do all of this on the calculator, it comes out 31.25, which is 31 1/4 if you want to do it in fraction form. But that's the total. Like, it actually, even though I add forever and ever, because the pieces are going to get smaller and smaller and smaller, it has what we call a limit to how big that sum can get. Now think about arithmetic sequences that wouldn't work, because there's no way to make the numbers really get smaller and smaller in the same way. Only works for geometric, and only if R is a nice fraction that's smaller than 1. Okay, so let's look at the next one. So I'm going to do negative 40 plus 20, negative 10 plus 5, and we're going to do that infinite sum. So my A1 is negative 40. What am I multiplying by here? They're getting smaller, so you know it's a fraction. So you have to just 1/2. Ah, negative 1/2. So my R is negative 1/2, because 20 is half of 40 and 10 is half of 20, but the signs are changing. It's going negative, positive, negative, positive. So I know I'm multiplying by a negative. So my infinite sum would be negative 40 over 1 minus negative 1/2. So if you wanted to strictly do calculator, you would type in negative 40 divided by parentheses 1 minus negative half, or you could put in 0.5 there. And it will give you this negative 26.6 repeating, which is the same thing as negative 26 2/3 if you want to change that back to a fraction. And your calculators will change that back to that improper fraction if you want to use that as well. I don't care. Okay? So if I do a series like, let's say I have 1 plus 5, or actually, let's do a different one. I already used 5. So let's say it's, now I can't erase it. Oops. Let's say I have 1 plus 4 plus 16 plus 64, ta-da. If I were to go to do this sum and use the formula, I would get an answer, but that answer is not correct. There's technically no sum to this. Ah, and that's because, so your A1 is 1, but your R is 4, and that is bigger than 1. And if your R is bigger and the numbers are getting bigger and bigger, that means that there is no sum. And that's important to know. It can be positive or negative, but if it's that absolute value is bigger than 1, it's not a fraction less than 1, then there's no sum. And then I'm going to show you one more tricky one. If you don't have room, you could put it on the other page. 1/5 plus 3/10 plus 9/20. I'm going to show you another tricky fraction one. So I would always start with seeing if I can figure out if the top and the bottom are being multiplied by the same numbers. So the top looks like it's getting multiplied by 3. What's the bottom getting multiplied by? 2. So that means that R is 3 over 2. So ask yourself, is that bigger than 1 or smaller than 1?
Bigger than 1.
That's bigger than 1 because that's actually 1.5. So this one would actually have no infinite sum at all. Now you could find a sum if they wanted you to find the first 100 terms. You could use that formula from the top. But I cannot do an infinite sum that goes forever. Does that make sense?
Yeah.
So when they ask you for the infinite sum, that's where it doesn't work because these numbers are technically getting bigger. And if they get bigger and bigger and bigger, it's not going to do that thing we did with a square where it actually stops.